So we're here at the example table, and in this video we're going to talk about sketching two functions, f of xy equals sine of y and f of xy equals sine of x plus y. So let's start with f of xy equals sine of y. This is a function of two variables, so we're going to graph it in 3 dimensions. So let's sketch our 3 dimensions here, x-axis, the y-axis, and the z-axis. And for the moment, let's pretend actually that we're just graphing z equals sine of y. So we're ignoring the x-axis, and we'll sketch the graph of sine. And we know what the graph of sine looks like. Looks something like this. And actually, let's extend the y-axis in the negative direction, and we'll sketch the sine curve on the other side as well. Now, our domain, though, isn't just the y-axis, it's the entire xy plane. This formula doesn't mention x, so it better not matter what the value of x is. Well, of course it doesn't, because if we plug in the point 0, 0, well, we're only paying attention to the second 0, that's y. If we plug in 1, 0, we're still only paying attention to that second coordinate, the 0, so it's still sine of 0. So if we have f of 0, 0, that's this point here, that's sine of 0, which is 0. F of 1, 0 is still sine of 0. We ignore the 1. This is 0. What about f of 0 pi over 2? Well, 0 pi over 2 is right here. This is where sine hits a peak. That's 1. But, again, there's no x here. So if we look at f of 1 comma pi over 2, we get 1 again. So let's say this is where x is 1. Well, then this function is 0 at this point. If this is the point then where x is 1 and y is pi over 2, well, then f is 1 there. To get the rest of the graph, therefore, from this single sketch of a one-dimensional curve, we take this curve and we pull it along the x-axis in this direction, and we pull it along the x-axis in the negative x-axis direction. We fill in all these values because x doesn't matter. So let's sketch this. Not the greatest sketch in the world, but I hope that you can see that it forms this sheet. And this sheet ripples like a sine curve, straight perpendicular to the parallel to the x-axis. These lines going parallel to the x-axis because we've stretched it along the x-axis. Now let's look at something slightly more complicated. F of xy equals sine of x plus y. So again, we'll start by drawing our 3-dimensional space. So x-axis, y-axis, and z-axis. Now, in this case, we're dealing with something a little bit more complicated. It's not just completely ignoring one variable. Now the values of f truly depend on both variables. But there's no distinguishing them once you've got the sum. So if you know what the value of x plus y is, you don't know where it came from. So let's look just at where sine of x plus y equals 0. So this occurs exactly where x plus y is an integer multiple of pi. So when it's 0, sine is when what we input into sine is 0, sine of that thing is 0. When what we input is 5 pi, sine of 5 pi is 0. So at any integer multiple of pi, this thing is 0. Let's sketch a little overhead view of the domain. So this is the xy plane. It's the same xy plane. It's the one that's right here, only now we're looking down at it. So x plus y equals plus or minus k pi. Let's sketch some of these lines. X plus y equals 0. It's a line, it's a diagonal line through the origin. X plus y equals pi. Well, it's a diagonal line shifted. Now it passes through pi. X plus y equals 2 pi. Well, it's the same thing. We have another line like this, and we do the same thing in the negative direction. So let's think about what must happen between these lines. Well, we know these lines are lines along which this function is 0. So if we think back to the previous example, we can imagine this rippling occurring, only now the rippling occurs rotated 45 degrees. So we have this rippling occurring sort of along this way. Because remember, this is the xy plane, so we're taking this plane here and putting it right here. So one of these lines might look something like this. So now we have this graph rippling this way. In between x plus y equals 0 and x plus y equals pi, we know that sine increases to 1. So halfway between these, it's going to increase to 1 and then go back down to 0. Between pi and 2 pi, it's going to decrease to -1 and come back up. It's going to go up, then down, then up. Likewise, in the opposite direction, it's going to go down, then up. So I'm going to try to draw this, give you a rough idea of what it looks like. So we know that it's going to ripple something like this, something like this. And we have these these dotted lines are supposed to indicate that this thing is a surface. So now we have that same rippling occurring like this. Actually, this looks shifted all wrong, but you know where it starts. It starts here at 0, increases to 1, increases to 1, decreases back down to 0 at the next line. So it's that same rippling effect sort of moving toward you or away from you along this diagonal line going through the xy plane.